Hello everyone. Today we can discuss Neet-JEE Mains gravitation topic. Based on the Neet, I will derive the derivations and everything. First I want to explain about the Kepler laws. In the Kepler laws, we know it is Kepler 3 laws. First Kepler law, it is the law of orbit. According to the law of orbit, each and every planet is revolving in a particular orbit around the sun is called law of orbit or Kepler first law. Kepler first law of orbit, how we can define means every planet revolving around the sun in a particular orbit. Every planet revolving around the sun in a particular orbit, that is called law of orbit or Kepler's first law. So if you take it is a elliptical path. Planets are revolving in a elliptical path. Ellipse having the two focus. So two focus, one it is F1 and one more it is F2. Here from this end to this end, this one we are calling it is a semi-major axis. This is called semi-major axis, and this end to this end we can call it is semi-minor axis. So which one it is the long, that is semi-major axis, and which one it is the short, that we can call it is the semi-minor axis. In this one, for example, sun position it is at F1. Sun position it is sun at F1. Now I am taking sun at F1. Now according to the situation, the planet is at point P or the planet is at point A. When you take the planet is at point P, this is the nearest position. Planet P is at P position, that is nearest position from the sun. That we can call it is the perihelion. And if the planet position it is far from the sun, that we can call it is the aphelion. So nearest position we can call it is the perihelion, and farthest position we can call it is the aphelion. Now in this situation, O, this is F1O, and this is the center of the ellipse. F1O to O distance I am taking as the C. F1 to O it is the C, and O to A distance is the A. So this is A, because from here to here it is the 2A. This is A and this is C. Eccentricity of the ellipse. Eccentricity of ellipse is equal to E is equal to, you can write as a just OF1 OA. OF1 divided by OA. Here OF1 is nothing but a C. We mention it is OF1 is nothing but a C, and OA is nothing but a. So C is equal to, you can write as a E into A. Eccentricity of the ellipse E is equal to OF1 divided by OA. Here OF1 is nothing but a C and OA is nothing but a. Here sun is at F1. Now if sun is at point P, nearest position, if the sun is at point P, that is nothing but a nearest position. This RP distance is nothing but a. Here PF1 I am writing as a R1. Now the sun position is at P. F1P I am writing as a RP. This RP is equal to this distance we don't know. So at that moment, OP minus OF1 I am writing. OP minus OF1. Here OP is equal to, OP is nothing but a from here to here distance. How much? Total it is 2A. Half of the distance from here to here distance is A. So this is A minus OF1 is nothing but a C. According to this one, C is equal to EA. A minus EA. If I take common A, 1 minus A. So RP. If sun is at point B, RP is equal to A into 1 minus E distance. For example, if planet at A, when planet at P, this is planet at P, RP. If planet is at A, it is nothing but a aphelion. It is aphelion at long distance. At that moment, this distance we need to find out. That is A F1 is equal to I am writing F1O or OF1 plus OA. See here, thus if planet is at A, sun position is this one. This is sun. Sun is taken initially only at F1 position. From here to here distance we need to find out. So from here to here OF1 and from here to here OA. OF1 is equal to what is the distance? C. We take it. OA is equal to we know A. Here C is equal to, according to this one, C is equal to EA. So C is equal to EA plus A. What you can take common? A. So this is 1 plus E. I am taking planet position is at A. The long distance is nothing but a RE. Now one it is RP, one it is RE. So angular momentum. If I want to apply for this one, conservation of angular momentum. Angular momentum means, what is the angular momentum at point P is equal to angular momentum at A. Conservation of angular momentum. What is angular momentum formula? mvr. So mass of the planet does not change. Mass is constant. Velocity of the planet at point P and distance r, that is equal to mass of the planet, velocity of the planet at A and distance when planet is at A from sun to planet. So both side mass get cancelled. We can write Vp divided by velocity of the planet at P divided by velocity of the planet at A is equal to RA divided by RP. Here RA is equal to, we know, A into 1 plus E and RP is equal to A into 1 minus E. Both sides A get cancelled. Vp divided by VA is equal to RA divided by RP is equal to 1 plus E divided by 1 minus E. This one you can apply in terms of the conservation of energy also, because velocity at P we know it and velocity of A we know it. Means kinetic energy equation of mv square. If you substitute, we can get another equation also. So it is in terms of the radius and in terms, that is radius means in terms of the distance and in terms of the velocity. I calculated in eccentricity 1 plus E divided by 1 minus E equation. This is the final equation from the Kepler's first law. So we have this Kepler's first law one equation. Vp divided by Va is equal to Ra divided by Rp is equal to 1 plus E divided by 1 minus E. Just I am repeating once again Kepler's law. What is Kepler's law? Law of orbit. Kepler's first law is nothing but a law of orbit. What is law of orbit means? All planets are revolving around the sun. All planets are revolving around the sun in a particular orbit. That is called law of orbit. Now it is ellipse shape I taken. This is the semi-major axis and this is semi-minor axis. As if the sun position is at F1, if nearest position, if the planet is at point P, this is nearest position from the sun. That is, we can call it as perihelion. If the planet is at point A, that is long distance, that we can call it as aphelion. And eccentricity of ellipse is equal to, formula it is E is equal to OF1 divided by OA, that is C by A. Now F1P distance I calculated, F1A distance I calculated. I applied conservation of angular momentum. This is nothing but a conservation of angular momentum. Conservation of angular momentum. LP is equal to LA. According to that one, I have written finally this equation. Okay. Now Kepler's second law. Kepler's second law means we have it is the sun and a line joining the sun and planet sweeps out equal areas in equal interval of time is called Kepler's second law. Means, for your understanding I am telling you, now the sun position is here, the sun position is, this is sun, and if the planet is position is P, it covers a line joining the sun and planet, a line joining the sun and planets. It sweeps out equal areas, in equal interval of time, that is called Kepler's second law. Now in this situation, we have to derive the one equation for this one also, because dA by dt is equal to constant, we have to prove it. Means in the definition only very clearly we mention it sweeps out equal areas in equal interval of time. It sweeps out equal areas in equal interval of the time. That is called Kepler's second law, isn't it? Now first I am taking at t is equal to 0. At t equal to 0, the planet position is at point B. After dt time interval, the planet comes to reach the point A position. After dt time interval, the planet comes to point A. Now this is the sun position, and from here to here distance I am writing as a r. That is the r, isn't it? Now I want to find out the area under the curve. It is nothing but looking like a one right angle triangle. This is nothing but we have to consider this is a straight line. It is one right angle triangle. So area is equal to half into base into height. Half into base into height. Here 1 by 2. Base is nothing but a r. Height is equal to, this is height, PA. Height is nothing but a PA. The planet is at point P. After t time interval, the planet position is here. So height is nothing but a PA, isn't it? It is equation number 1. Now what about this PA? That we have to calculate. Now while it is moving from point P to A, it subtends some angle at the center. That is nothing but a theta. It subtended angle at the center. That is the theta. This position I am considering as a O, isn't it? Okay. Angular displacement is equal to angular displacement theta is equal to length of arc divided by radius of the circle. See here, angular displacement is nothing but a theta. Length of the arc is nothing but a, this is PA. Radius of the circle it is r. So PA is equal to r into theta, that is equation number 2. PA is equal to r into theta, that is equation number 2. Substitute equation 2 in equation number 1. See here, equation 2 substitute in equation number 1. At that moment, area is equal to half into r. PA is equal to what it is there? R into theta. So we can get A is equal to half r square theta. Now I want to differentiate this equation with respect to time. I want to differentiate this equation with respect to time. dA by dt is equal to half into r square d theta divided by dt. dA by dt is equal to half r square. A rate of change of angular displacement is called angular velocity. A rate of change of displacement is called angular velocity. So d theta by dt we are writing as a omega, isn't it? Now dA by dt is nothing but a constant. According to the definition, we know very clearly it is a constant. A rate, it sweeps out equal areas in equal interval of time. It sweeps out equal areas in equal interval of time. So that's why dA by dt is the constant. In this definition, I am writing here only half r square omega. Okay. Otherwise, here only I will write m r square omega divided by 2m. I multiplied this equation. I multiplied and divided this equation with the mass. I multiplied, divided this equation with the mass. Here m multiplied and divided by this is 2 as well as usual. R square omega also as usual. R square omega, it is nothing but a moment of inertia. mr square is nothing but a moment of inertia formula. So we can write here, we can write I omega divided by 2m. I divided by 2m. I omega divided by 2m. I omega is equal to L, angular momentum. I omega is equal to angular momentum, that is L by 2m. So dA by dt is equal to, we got it is L by 2m. According to the definition, very clearly we know it, dA by dt is equal to constants. At that time L also constant, angular momentum also constant. Angular momentum is constant means we can write the equation, it is m v maximum r minimum. Okay, otherwise for your understanding easily I will write mvr is equal to constant. Mass is constant only. V inversely proportional to r. V is according to the angular momentum. L is constant. L is constant means L is equal to mvr. So here r, if I taken this side, V is inversely proportional to r. If velocity is more, distance is less. For your understanding here, this distance is more. Distance is more means what about the velocity is less. Distance is more means velocity is less. Means the planet from here to here, it is moving, it is nothing but a velocity is less because distance is more. For example, if the planet is moving from point C to point B, here distance is less. Distance is less means what about the speed is more. So that's why it can obey the law of conservation of moment, angular momentum. It can obey the law of conservation of momentum. According to this one, when distance is more, velocity is less. When distance is less, velocity is more, isn't it? So it obeys the angular momentum, and it can be, according to this one also you can write, it can covers equal areas in equal interval of time. That is dA by dt is equal to constant. So formula dA by dt is equal to L by 2m. Just I will complete it. What is definition of this Kepler second law? The line joining of sun and planet sweeps out equal areas in equal interval of time. That is called Kepler's second law. That is called Kepler's second law. Initially at t equal to 0, the planet position is P. After dt time interval, the planet position is A. So it covers this much of area. Area is equal to half into base into height. This is base and this is height. Height is nothing but a PA. Angular displacement is equal to, we know it is length of arc by radius of the circle. When it is moving on the elliptical path, it subtended angle at the center. So theta is equal to length of the arc by radius of the circle. Length of the arc is nothing but a PA. That PA divided by R. So PA is equal to R into theta. This equation 2 I substituted in equation 1. So finally I got like this. I differentiate this equation. Here d theta by dt is nothing but a omega, angular velocity, and this equation only multiplied and divided with the mass. Here mr square is nothing but a moment of inertia. I omega is nothing but angular momentum. So dA by dt is equal to L by 2m. dA by dt is equal to constant. L also constant. V is inversely proportional to R. Okay. Now we can discuss about the Kepler's third law. See, Kepler's third law. The square of period of revolution of the planet around the sun is proportional to, means a square of time period. Square of time period, that is t square. Square of time period of revolution of a planet around the sun is proportional to cube of average distance of the planet. We can take cube of average distance of the planet, otherwise within the bracket I mentioned, that is semi-major axis of elliptical orbit. Semi-major axis. Semi-major means what I given the symbol, it is A. In the initially Kepler's first law while I am explaining semi-major axis A and B. B is nothing but a semi-minor axis. So I can give it is nothing but a 3. T square is directly proportional to A cube. T square is directly proportional to A cube. This one we can derive like this also. The gravitational force equation, F is equal to, what is the formula? Capital G, mass of the planet and mass of the sun, mass of the planet divided by A square, distance. It is nothing but A square is the distance. And here F is nothing but a gravitational force is balanced by the centripetal force. When planet is revolving around the sun, when planet is, this is planet, it is revolving around the sun. The sun position is here, for example, it is revolving around the sun. At that moment, centripetal force is acting on the planet. This gravitational force is balanced by the centripetal force. What is the centripetal force formula? M R omega square is equal to G capital M small m divided by A square. Both sides, mass of the planet get cancelled. This is mass of the planet both get cancelled. Centripetal force, you can assume here, actually centripetal force is nothing but a mv square by r. V is equal to r omega. If I substitute, we can get centripetal force formula, this one. Centripetal force formula, it is mv square by r. But we know V is equal to r omega. This r omega, if I substitute here, I can get this equation mr omega square. So both mass get cancelled. Equation it is r omega. Omega means 2 pi by t. Omega is nothing but a 2 pi by t. That G capital M divided by A square. Omega is equal to 2 pi by t. Now whole square is then whole square applied. In this one, see here, in this one, r whole square means 4 pi square divided by t square, that is equal to G M divided by A square. Okay, but here A is there, here R is there, means the distance I taken A. So this one I am writing as A for our understanding. The distance I am writing as A, not R. The symbol should be same. mr omega, actually V is equal to r omega. This is formula, but we consider distance is nothing but A. So that's why this is A. So A, if I taken this side, what we can write here? This is A, 4 pi square divided by t square, G m divided by a cube. Reverse order, t square divided by 4 pi square a cube divided by gm. 4 pi square I am taking that side. 4 pi square gm a cube. T square is directly proportional to a cube. Here 4 pi square divided by gm is the constant. See once again, according to the definition we can write t square directly proportional to a cube. Here a is nothing but a semi-major axis. When planet is revolving around the sun, gravitational force between sun and planet is nothing but a m divided by a square. This gravitational force is balanced by the centripetal force. Centripetal force m a omega square. And both side mass of the planet get cancelled. Omega is equal to 2 pi by t whole square. So squaring on, if I apply here, a I am taking this side, a cube 4 pi square t square gm by a cube. In reverse order, denominator I have written numerator I have written denominator like this. 4 pi square I have taken that side, t square is directly proportional to a cube. This is the proportionality constant. This 4 pi square divided by gm is the proportionality constant. So t square directly proportional to a cube. According to the definition, the square of time period of revolution of the planet around the sun is proportional to cube of average distance of the planet and otherwise semi-major axis of the elliptical orbit. This is the equation.